Hello everyone, Molo, Dumelang, warm welcome to you. Hope you will enjoy this session. So today we will be mainly looking at project management and research reproducibility, and also this also ties in with how to effectively plan your career. So now in previous sessions we've looked also at other components that are very important in planning your career. I remember the first session was about choosing a research discipline and choosing your supervisor and doing the literature review and getting grant funding. So all of this is very, very important in planning your career. And in future, there will also be additional sessions besides this one on how to publish and how to present well. And these are very, very important skills you need to learn during your M and your PhD studies. So besides writing papers and attending conferences, you need to learn also what we call the soft skills in research, and that is project management, leadership, and that kind of thing. And all these skills you need to accumulate during your career. So as I said, a large proportion of your work will be focused on your experiments, your research, writing up your thesis, but you need to also be cognizant that publishing this work and presenting it at conferences is very, very important for your career. Having a mentor is important, having a good supervisor is important, and then also very importantly, how to effectively plan your project and finish it in time and delivering on your objectives. Okay, so what we'll be focusing on today is mainly research reproducibility. This is very, very important. What we'll be discussing is what is research reproducibility? Why is it so important? How do we go about it? How do we achieve it? And some points we should keep in mind along the way. Remember, research ethics and ethical conduct of research is also extremely important. We'll be discussing a bit about that as well. In previous sessions, we already mentioned that it's extremely important when you are working with humans, or if you are working with animals, it's important to get ethical clearance in advance. Normally, these committees have dates during the year that they meet, so have a look on their website and plan that you submit your proposals and all the documents required that is usually listed on their website before the committee meets, so that they have enough time to receive your application, review it in time, and then get back to you with the approval number. And then every year you also need to follow up on the ethical approval. You need to feed back and you need to double check what's going on. And this process can take quite some time. So for those in medicine or in other studies, physiology, it's important to apply in advance, well in advance. Then we'll be also look at project management and how to effectively plan your career and why this is so important and how can we go about this. Right. So now the first point that we'll be looking at is it's important to conduct ethical research. So besides applying for your ethical clearance when you are working with human or animals in your research, it's important that we keep doing research that is ethical. What do I mean by that? Most funding applications also nowadays emphasize that there needs to be gender equity, inclusivity, and know where you kind of misinterpret data or misinterpret p-values or use the wrong statistical approach or the wrong method. So avoid these kind of things, but we'll be going into a bit more detail about that later on. So remember, we need to be very cognizant of research integrity. Now, there's a lot of information on the internet. As I said, remember, we only have 1 hour and a half, and This is little time to cover everything, but as I already mentioned previously, it's very important for you to attend other workshops on these topics. Look for this on the university webpage internationally and attend them. There's also a lot of documents available online and also very nice papers also on your different journals and also on Nature careers that you can have a look at on research ethics. So always supplement your knowledge. If you attend a workshop, also attend others to complement your knowledge, okay? So if we look at the broad overview of ethical research, it's important, like I mentioned before, to apply for your ethical clearance. Then research integrity is very, very important. Being cognizant of inclusivity in your research, addressing your sustainable development goals in your research, not misinterpreting data, or not giving false data, or leaving out data that is not will not achieve your end aims, all of these. So avoid at all costs these, because journals and editors can pick up on these things. Also plagiarism. This is also a form of where research integrity is not followed. Then it's very important also when you publish that you declare your conflicts of interest. Are you advising a pharmaceutical company? Are you advising the public sector? Are you getting incentives or honorariums for that? You need to declare that. Also mention the funding that you've obtained for your research and also the funding number. Right, when you're in medical research or in animal research, you need to have respect for your research participants. You need to handle them with a lot of empathy, a lot of care, because they are important for your research project. This is very important. And also when you include any sensitive data that you obtain from them, ensure that the data is anonymized. Make sure that you cannot link a participant's name with a specific data set. You can have that information, but you keep that confidential to you and your supervisor. The rest of the members of the team should not have access to this information. So there should ideally be two sets of data files, one that is anonymized and one where you have all the original data in with the patient name as well. So this is very important. Also, for example, if you publish a photograph of a patient in a paper, you have to cover the eyes, and sometimes the journal will also give you guidelines on how to handle sus matches. So have a look at that and be very cognizant of that, right? Then also when you are working with data, if you are in science or other disciplines, and when you collect data, you need to ensure that the data or the number of samples you collect has enough statistical power to reach statistical significance. And if you are unclear about this, it's always good to have a chat with a statistician, explain to them this type of study that you are planning and your aims and what you want to achieve with this study and how many groups you have, what is the differences between the groups, and ask them to do a power analysis so that you have sufficient number of samples so that you have valid data at the end. Then also follow the ethical guidance when you apply for ethics clearance. There's a lot of documents that is required. For example, participants need to complete informed consent forms. Sometimes the ethical clearance office will provide you with such forms. For example, if you're working with minors, you have to have the parent also present during the study or giving informed consent. So have a look at all of this. Remember that your research should help society. There should not be any social injustices or any misuse of participants or injury or damage to animals. Okay, so be very, very cognizant of these ethical guidelines in research. As I mentioned, there's also a lot of documents available on the internet describing this. Now, when you're performing thinking about the principles guiding the ethical conduct of research, we can think again about a number of different aspects related to this. So we have to remember there should be a reasonable risk to benefit ratio. There has to be acceptable risk benefit in the context of the population study. So minimize the risk for the population. Sometimes if you apply for ethical clearance and you can explain that this is minimal risk research. For example, if you looking retrospectively at patient data, then you can ask for an expedited review of your ethical clearance because this is minimal risk. But if you're doing clinical research, there may be a risk to your specific population. For example, you may be giving them a test medication and they may have some adverse reaction to it. So these are all things to be cognizant about. Then the validity of the study, and this also links into, is the study reproducible? Will someone else be able to follow the same method and then find the same outcome? Sometimes this is difficult if you're working in different settings, especially when you're working with people, because if you're doing a study, for example, in one country, the results may not match if you're doing it in another country because the climatic conditions, the diet of the people, there's different factors that can influence this. But in bench type of research like science, the science need to be repeatable, right? And also for this, we need to well design our study. We need to think about power analysis to reach an effective sample size. We need to think about the appropriate methods to follow. We need to read other papers to see what has previous researchers done, what are the limitations in these techniques that they use, and how can we improve this to provide a well-designed study in terms of methodology, sample size, study design, and also your statistics that you follow. And at the end, how you present all of this and how you interpret this. Okay, how you interpret and discuss your results is also very, very important, because in many papers you'll see that in the discussion section there's a lot of repetition about the results of this study, but not actually a discussion of the implications of this work, what it would mean to society or for fundamental or applied research, and where are you going to go from that point on. So collaborative partnerships is also very important. Think about who you collaborate with and how it will benefit you and the team. Collaboration across different countries, both in developed and still developing countries, is very important. Involving industry in your work is also very important. And when you have collaborative endeavors, it's important to share resources and funding. For example, when you publish a study and there's a high article processing charge involved where you have to pay the journal to publish your study, you can share this cost with your collaborator overseas. Ask them. This should be shared, the cost, because sometimes for less economically well-off countries, these article processes charging are very expensive and we cannot bear the cost on our own. Very important, think already at the very start of your studies, what is the social value of your work? How will it benefit communities? How will it address one of the sustainable development goals, etc.? Okay, so think about the impact of your work. Sometimes not all work will have impact. Sometimes you will do a fundamental science study, but in the long run, this may also have implications for applied research, as we discussed in previous sessions. Then, very important, if you're working with humans or animals, have equal and moral respect for participants and the affected communities, right? This is very important. For example, if you are doing a study involving a traditional community, it's important to discuss what you want to do with the elders or the community leaders, to speak to them in their own language so that they are clear and that there's no unnecessary exploitation of them and their knowledge. This is very important. Involve them in the processes of the study. And there's also nice articles in this nature career section, where they explain the importance of involving societies, for example, citizen science research, and involving indigenous communities in your work and your studies, because these people have knowledge that have been accumulated over many decades, and this can really be beneficial for science and the advancement of knowledge. But these people's knowledge should never be exploited. This is very important. Then also, when you're working with participants, fair and voluntary participation is very important. If you're working with patients or humans, they need to sign informed consent. If you're working with children, the parents need to sign this informed consent. And we need inclusion when you are selecting your participants. Be inclusive of your inclusion, but also cognizant of your exclusion criteria. For example, if you're working with a specific population, for example, suffering from heart disease, you will want to exclude someone who is smoking, because this can aggravate heart disease. And this all depends on the eventual outcome of your study. So you need to think very carefully about confounding factors. Even when you're working with your pure science disciplines, one needs to think about the factors that can influence the outcome of your research. For example, if you're designing a study, for example, on how to manufacture nanoparticles, there's a lot of different factors that can influence their physical, morphological, and chemical properties, and this can depend on your pH that you use, the temperature that you use during the manufacturing process, the type of starting material that you use. So think about very carefully about all of these things. And then remember, your ethical review and your papers will also go through an independent review. When you suggest reviewers, especially for papers that will be published, you should not suggest people that you know. This should be people independent from your own research and your research group, and you recommend them. Okay, so let's look at just in general, when you are compiling right from the start to the end, when you are compiling your research, when you right at the beginning of your research study, when you are thinking about conducting ethical research, very important at the very beginning, you start with your research question. Is this really necessary? Does it address a sustainable development goal? How will it benefit a community? Right? Then when you look at your proposal development stage, you will look at collaborations. How will this benefit you? Will there be sharing of funds, sharing of equipment, and very importantly, sharing of knowledge? Will there be some lab exchange? Will you be able to go to the lab abroad and learn very important skills for your career development? Do you need to apply for ethics, and is the methodology that you use sound? Now, very important here, if you use working with humans or animals, you want to protect your participants from any harm, and you want to treat them very fairly. You will want to anonymize any data that you collect from them that is especially sensitive, and you want to share with them the outcome of the data, because this may be beneficial for them. For example, if you develop a new treatment or something like this, you want to share this knowledge with them. Then when it comes to your data collection, one needs to think about how you're going to compile the data in Excel, or what kind of program are you going to use to store this data? To whom is it going to be accessible? Remember to make backups, because things can happen to computers and then the data may be gone. So remember how you store the data, and also how to summarize the data in such a fashion that someone else can be able to use it. And now there's also a very much importance put on publishing open data. So the journals will ask you to deposit your data in an open data repository, and then you need to summarize the data in such a way, for example, having nice column headings so that someone else will be able to interpret what is this column's data referring to, so that he or she can reuse this, adapt it, or do different statistics on it for their work, right? So this is very important to think about open data. collecting the data in such a way and presenting it in such a way so that someone else can also be using it. Then very important, when we're done with the study, we need to disseminate the results. There's no point in putting in all of this hard work and then studies are not published. No one sees it. So we have a very much obligation to publish work. For knowledge exchange, we need to attend conferences and we need to disseminate the work that we have done, right? Then sometimes, and not all research, sometimes our research may influence policy. It may translate into some practice or something, and it may have some long-term impact. And that is important right at the beginning of your research to think about what impact will my research have? Will it change some policy? Will it help a community? What will be the end product of the research besides just advancing the knowledge? So these are the different steps that we need to be considerate of. Already starting at the idea, the proposal writing, the ethical writing, the data, and the dissemination, right? So now we're done with conducting ethical research. So we're done with that now. So now another component that we need to be cognizant of when we're planning our research and planning our project is doing research or describing, eventually when you publish your work, describing your research in such a manner that someone will be able to reproduce it. Now, this is something that we commonly see in, for example, nanosciences, where someone will report the synthesis of the nanoparticle and they don't include the concentration of the starting chemicals that they used or the experimental conditions, and it will be very difficult then to repeat this research because the information provided is not very clear. Now, there's a lot of different reasons why scientists avoid mentioning everything in papers. They may be afraid that someone else may take over their discipline or publish more papers than them, or competition in science is always a very sensitive issue, but since science should be for society, conducting reproducible research is extremely important. So understanding just again how the whole science or research discipline works is obviously we start by formulating a hypothesis, we design the study, we run it, we collect the data, we analyze it, and we report it. Now, where the research reproducibility really comes in is in already when we're designing it and when we're running and analyzing data, we should keep a journal either on the computer or in a lab book that documents everything, the methods that we followed, some challenges that we may have ran into and how we're going to address this. And then very importantly, how we report the data. If we report our methods, we need to think about when we read the methods, is this sufficiently written so that someone else can repeat the study? So this is extremely important. And now, why are we discussing this? Why is it so important? Because the public trust in science is failing. Here we can also see some articles that have been published that are critiquing research reproducibility, and this now we can understand why this is so important. Look at this first article here, this research correspondence. Believe it or not, how much can we rely on published data on potential drug targets? Now, especially when you're working in chemistry or the pharmaceutical discipline, we need to reproduce work that is reproducible, because if we're going to develop a drug, it needs to be tested in a proper fashion, maybe in a different setting, and then someone else needs to be repeating this work so that it delivers the same result as the original study, right? Then look at this interesting one. You can go and read this, why most published research findings are false. And then power failure. Why small sample sizes undermines the reliability of neuroscience. Now, especially coming back now to if you're in the medical field or any type of field related to biomedicine or this type of fields, remember these type of studies are used to build the evidence base in science. So if we have one study that is not reliable and ethically conducted, it will influence the outcome of further studies, because someone may see this, they may repeat the same method, and then they may not get a good enough result. Particularly if you're using a small group of people and not representative of your actual aims of the study, and if you include, like for example, participants that doesn't fit the inclusion exclusion criteria linked to your eventual goal of the study, this may you may get then false data. So be very cognizant about this, that your sample size that you use is very important. If you struggle, go and see a statistician, and always when you're planning your research, go and read journals in high impact journals. So what do I mean by high impact? So when you go to the journal's website, you look at the impact factor of the journal, and this should ideally be above 3 or 4. And then you sometimes also go to reputable journals like Nature and Science and those high impact journals, because you know that these studies go through very rigorous peer review before they get published. Right, so let's look at this. So what really is then research reproducibility? So this really ties in with the analysis and testing. So if you've completed the study and if you've published it, and when someone else reads it, will they be able to replicate it? So this is very important. Replication of findings of the highest standard is important to evaluate and produce evidence. Focusing on validating the science claim, this also links to research reproducibility. Remember, we require transparency in our methods, in our data. Remember what we talked about open data. We need to publish data in open data repository so that someone else can get access to that data and maybe do some further statistical analysis or use it to complement her or his own data. And this is basically research reproducibility is the minimum standard for any scientific study. So this is very, very important to well represent and write up your work. So why should we practice this? A study report, remember, is not enough to assess the sensitivity of findings to assumptions. We need to replicate that. Sometimes in research, one needs to replicate research results several times before one can reach a conclusive outcome and decision, and especially in type of drug studies and medical studies. Remember, it's important to distinguish confirmatory from exploratory analysis. It's important to identify deviations from a specific protocol and why this was done. We cannot evaluate the study analysis and finding using one study report. This is not enough because, for example, researchers may use different approaches also to analyze data. They may use different statistical methods that may also influence the data. So that's why it's important to very clearly outline your methods, the techniques you followed, why you followed a specific statistical approach, and then correctly interpreting such statistical findings and correctly summarizing them in figures and tables so that someone else can be able to really critically review your work and maybe redo it with another setting or another sample, right? Now let's again, this is mainly related again, research reproducibility is how you analyze your data and how you report it, as I already mentioned. So this is important. Now there's two types of approaches one can go through in research reproducibility. Remember, there's the idealist. You want to stand on the shoulder of giants minimum, you have the minimum scientific standard, allows others to build on your findings. You want improved transparency, increased transfer of knowledge, increased utility of your data. So this is one type of person. Then you get another type of researcher that likes data sharing, citation advantages. It takes some effort to organize the research to be reproducible. The principal beneficiary is generally the author itself. Improves capacity for complex and large data sets or analysis, increased productivity. So there's different schools of thoughts of how to approach this. Okay. Now, if we look, how can we make the research producible? If we start right at the beginning, like we already said, we're at the very start of your studies already. Before you even start your work, you go and discuss with your supervisor, what is the best design for my study, right? What type of approach to my study will I use? Will I use the randomized controlled trial? For example, will I be using a retrospective review? If I'm working, for example, in botany, if I collect plants from a growth trial, how will I collect these samples? Will it be in a randomized design, for example? So discuss the approach to how you're going to collect your data and how many samples you should have. Then very important is already at the beginning to discuss the data management plan. Who will have access to the data? Where will it be stored? For example, on a Google Excel sheet or on a private Excel sheet that you will share with your supervisor or the other colleagues involved in the study. Will you publish this in an open access journal? Remember, publishing open access is very important. Then also, if you're working with patients, you must ensure that data is anonymized. If you're having sensitive data, in general, it's important to anonymize any patient data. You need to think about if you are doing, for example, if you're doing environmental studies, you need to properly describe your location, that you've sampled materials from, what is the climate, what is the geography, what is the location, any factors that may be relevant for someone else to reproduce the work. Also, if you're doing experiments even before you start your work, just to see if something works, carefully plan this. Then very important, keep track of your data and your documents. For example, if you're sharing a draft of a thesis that you are working on, remember to mark this with the dates, because sometimes when there's a lot of revisions involved and there's a lot of emailing to and from supervisors and collaborators, one can get easily confused with which draft is the most recent one. So keep track of your documentation and keep backups of that. Remember, bias in research is also a very big dilemma, because sometimes people will only report on positive results and leave out the negative results. Remember, even if you have negative findings, it is good to report this. Sometimes also what people do, they will falsify data. They will leave out data that will skew the data set or not achieve their actual goal with the data. So do not do this. Editors and reviewers, they may pick up on these things, because remember, they are experts in their fields and they can pick up very easily. Also plagiarism. Run your work through a plagiarism check so that you ensure that you don't commit any plagiarism, etc. Right? So now, let's talk about the power, like I already said. So it's important right at the beginning of your work to do a power analysis, to calculate the power to achieve statistical significance. So how many samples should I collect or work with to, at the end of the day, achieve statistical significance in my study. If we're working with a few samples, there may be a low probability of finding true effects or low probability that a positive or true positive outcome will be there. Exaggerated estimate of the magnitude effect when true effect discovered, and a greater vibration of effects. This may all happen when you have a low number of samples, if you're working with a low number of samples. However, the problem with this is that sometimes you cannot always use a large amount of sample. For example, if you're working with certain techniques, like for example, if you're using elemental mapping techniques, if you apply, for example, to make use of an instrument, sometimes mapping elements takes an enormous amount of time, and you only get a set time to work on the instruments because it is fully booked, and then you cannot analyze so many samples. So then you have to be very careful how you plan and execute the study to still get a reproducible result, right? Estimate the size of effect that you are studying. What is the effect size? This you can also talk to your statistician. Will be able to advise you more on this. Design your study with sufficient power. This we already discussed. And remember, if your study is underpowered, you can report and acknowledge this as a limitation in the interpretation of your results. Sometimes when you're doing, for example, a pilot study, this will still be allowable because you're just having a pre-type of quick small study just to check whether this work will eventually deliver some result. So that in some cases can be allowable, but be careful, then you have to highlight this in the limitations of your study in your discussion section. Then you have to mention that the reason why you use the small sample size, because it may have been a pilot study, or there may not have been a lot of people that signed up for the study. Why was this? And then you need to mention this and how you're going to address this in future, right? Then very important, your data management plan. And you need to share your data. This is very important. Share your data with your supervisors so that they can scrutinize this with your collaborators. It should be well managed from the start to the finish, how you collect it, how you report it, how you share it. And when you also report your data in your Excel sheet, ensure that the variables that you describe is easily interpretable. So every column that you assign to a different data set, label them clearly so that someone else can really understand what is this data, what is the meaning of this data, what is it relating to, etc. Right? Then choose a type of format that you can use. You can use Excel. Sometimes when you input data into certain programs, it needs to be in a specific format. For example, when you're doing some heat map analysis, for example, to see if there's differences between group. This is now related to statistics. The data need to convert it to a CSV file. Then, for example, you need to have an Excel sheet that you can transform to the CSV file. So make sure that you summarize it in such a way that you can also transform it into a different file format. For example, don't go and summarize data in Word, rather use the Excel, or in Google. Excel is also good because then you can provide a link that you can share with your supervisor, and as you update it, the supervisor can just check using this link, or your collaborators. Then very important, storage of your data is important, where you store this, and backups is important because computers may get lost or they may break and then the data is missing. Now, as we already mentioned, have a nice informative name for your data. And what does it really relate to? Is it data linked to a specific variable? Data linked to a specific group that you analyzed? What group is it? Group A. If you mention, for example, in your column, this is group A and group B, this is not informative enough. Is the group A your control group? Is the group B your test group? Or what does this really relate to? Because remember, after many months, when you come back, you may forget what was group A, what was group B again. Also, even in your, when you're doing experiments, and you mark your vials. Mark it very clearly with a date and a label and what is in it. Because when you come back after a couple of months, you may have completely forgotten what is this. I cannot remember. I don't know what is number 1, 2, 3, or 4. So always be very clear when you describe your data, right? This is again, for example, like if you're providing dates, for example, in a certain format. Remember, if you write dates, for example, in the year, month, date format, write this down somewhere on the column in the data set or in your private notes set, so that you know this is the year, the month, and the date, and not year, date, month, something like this. Okay, so also important how you order your data. It's also sometimes important when you go and see a statistician to ask them how they would like the data to be ordered. For example, dependent variables, do they want them in rows or columns, or they want the dependent variables in a row or a column. So ask them what will be feasible for them and readable actually to work with, okay? Then sometimes if we are working in the medical field, sometimes pre-registering a study plan is important. Sometimes your supervisor will also be able to advise you on this. You will have to describe the hypothesis, the design, the sampling, the power, if the data was randomized, and then specific variables measured, and then the data processing. Okay, and this counters basically selective reporting and outcome reporting bias. It distinguishes a priori design decisions from post hoc. And this is only relevant for certain types of studies where you have to pre-register a study plan. And this is normally sometimes mostly for clinical trial type of work. This is not relevant for all type of disciplines. This is mainly only focused on type of medical research, right? This is also related to this. This is important so that other people can also review your data analysis plan and ensure that it is reproducible. You will define your data analysis set. Very importantly, what statistical analysis you'll be using, descriptive statistics where you summarize the means and the standard deviations, and then secondary and exploratory statistics where you will doing more multivariate analysis on the data. And which types of analysis should you be working? Because remember, statistical data is also, statistics in itself is a very complicated field. Which statistical test you use will determine what type of outcome you have and what type of data you will, or meaningful data you will obtain from your work. For example, if you're doing certain type of more advanced analysis such as principal component or linear discriminant analysis to see if there's differences between the groups. Now, if you select one method, for example, for the principal components, the data needs to adhere to specific principles, and all of these one needs to discuss with the statistician. This is my data. This is what I want to achieve in my study aims. What is the best tests to use to look for example, differences between groups or relationships between groups, or if there's some correlation, etc. between groups. Also ask them how you're going to handle missing data. This is very important. How you're going to handle outliers, okay? So this is very, very important that you have your raw data at the beginning, but then consult with your supervisor or the statistician before you present them with the analytical data. There may be some outliers or some missing data. How are you going to handle this? Because this may greatly influence your results. If you leave out outliers or how you input missing data, this can greatly influence the outcome of statistical analysis. Okay. Also, like we mentioned before, if you are working with different versions of your data or different versions of your manuscript, be very careful of how you write the file name. For example, when you go through many revisions of your thesis or your paper, you may get completely confused with what version you have worked on most recently. So always include a date and a time maybe so that you know exactly this is my most recent version that I need to work on. Okay. Very important when you are working with doing your experiments, you want to document everything. You want to document the type of instrumentation that you used, especially if you're working also with screening type of surveys in psychology, where you are using different test batteries for different types of population. You need to ask yourself, has these tests been tested for reliability and validity in a specific population? Groups, document also the software that you use and check that it's the latest version of the software that you are using. Be very careful of documenting every single thing that you do, and making sure that someone else can then get access to that and do the same experiment in the same way and get the same results. Okay. Reporting should also be transparent and complete. So transparency means readers can use the findings, replication is possible. Findings can be pulled into meta-analysis. So sometimes in, for example, your biomedical or your medical studies, you will have these types of studies where researchers do systematic reviews and meta-analysis, where they review the data and they review certain studies and they be very specific of the studies that they select. And then they reanalyze the data using very complicated statistics. And these type of works is very important to provide an evidence-based for medicine. For example, they will plan a very specific study, for example, on the factors that influence heart disease, and then they will have very specific search criteria to get these studies on the internet or do literature searches. They have very strict criteria for what studies to include and exclude. And then they will collect all of the data that is in open data sets published by the journal. And then they will redo these complicated statistics to reach a conclusive result that will be used in the evidence base for medicine. So that's why it's important that the research is reproducible and that there's valid data being reported. Okay, sometimes in some fields, for example, in medicine, they will also have specific guidelines that is published, and you have to follow such a guideline when you are doing a specific study design. For example, the consort statement. So when you're doing a specific design, you will have to consult. Sometimes the journals will also outline this for you, that go and check the consort statement or this statement and go and check if your reporting is according to the statement and if the methods that you followed, etc., is according to the statement. This sample is also, this one here is important for statistical analysis and methods in the published literature. So go and have a look at that as well to just have clarity. Then bias can also come in where you have missing, like for example, when you exclude missing data or you exclude outliers, which can have a very, very big influence on your data. Also report on why you deviated from your original study plan. For example, you may not have reached your allocated sample number because maybe not all patients wanted to be part of the study. Then you need to explain why as well. For example, if you had a small sample size, you also need to explain that. So that's also very important. Then also, we already mentioned that sharing data is important, and normally the journals in which you aim to publish will also guide you on where you should share this data. And you should also include where you are sharing the data, the database that you are using in your publication. You should mention that you can find the open data or the published data at so-and-so link, at so-and-so website, etc. Or sometimes you can just mention that if authors want access to my data, then they can contact me personally. Okay, so let's look now at the summary of when we are planning our studies to produce reproducible research. So first, do the power analysis so that we can see we have enough samples to reproduce and achieve good statistical findings. Prepare to share your data management plan. How will you manage the data? Which programs will you use to summarize your data so that these are accessible to your supervisor, to statisticians? Informing naming location. Remember, you have to be clear of, for example, if you're doing an environmental study, you need to describe the location of your study and the environmental conditions, climate, etc. If you're doing in certain studies, for example, in medical studies, if you have a study plan, you can pre-register your plan, and this will then be reviewed by other workers in this field to see that you have a solid plan. Remember to keep track of things, to contain bias in how you report data. For example, don't leave out missing data, or don't leave out outliers. Discuss this with your statistician and your supervisor, who will give you the best advice on how to handle this. And remember to archive and share your materials. And if you're sharing your materials, especially if you're working with patients, you need to anonymize the data. And here is some more additional information that you can go and read. Organizing a product for reproducibility. This is a nice paper of reproducible science curriculum by Jenny Bryan. Data management, how to share materials, version control, and also about literate statistical programming. Okay, so you can consult these sources. Then also, again, in summary, remember that your method should be valid and it's organized in such a way that someone else can use it. It is transparent. You describe in such a way that someone else can use it. For example, you describe fully the chemicals that you use, the concentrations that you use, the conditions of the experiment, how long, for example, did you synthesize, for example, a nanoparticle using which starting materials, at which concentration, at which pH, at which temperature. For example, the methods needs to be accessible. The data needs to be accessible, and the reporting is very important in how you interpret your results and describe and discuss them. Right? Now, there's issues in reproducibility in science. For example, you have this data dredging, where it's also known as p-hacking, and this involves repeatedly searching a data set or trying alternative analysis until a significant result is found. So this is a common problem in research reproducibility, this p-hacking, because remember also how you choose your p-value can also influence statistical outcome, the type of statistical test. If you're using a statistical test that is not fitted to the type of data that you're having or not fitted to the type of outcome you want, you will also may get invalid results. The next one there is omitting null results when scientists or journalists decide not to publish studies unless results are statistically significant. This is also wrong. I mean, studies that produce negative results is also important to see because one needs to understand why. For example, we recently produced a study where we tested nanoparticles and whether they have antimicrobial effects. Now, we found that the nanoparticles were not highly antimicrobial. They didn't have a lot of antimicrobial effect, but they had a high cell toxicity effect. Now, this may mean that although they don't have antimicrobial effects, they cannot be used against microbes, they may be used in other fields for example, cancer research. So even if you get a negative results, it should be shared, because this can have application in some other field, or someone else may pick up on it and see, oh, maybe this is the reason they got a negative result, because they didn't use the correct method, or they should have done this or that. So publishing negative results is also good. Then underpowered study, remember what we mentioned about having a small sample. You may not always have statistical significant findings, and it may not be representative of an entire community. For example, if you're doing, for example, environmental toxicity study, if you are going to, for example, sample or collect data from a small group of miners, if you want to check how their health is affected by, for example, exposure to lead or exposure to toxic metals within the mining industry. And if you're only using a small number of people in the study, you may not get a representative result. Because remember, people vary very much in their diet, in their bodies, and in the environments that they live. And this may also make them more resilient to the effects of exposure to toxic metals. And that's why it's always very important to sample a well-representative sample, and include enough samples so that you have a representative and valid sample. Very important here, weak experimental design. A study may have one or more methodological flaws that mean it is unlikely to produce reliable or valid results. For example, you may use the wrong technique to analyze a specific data set or a specific sample. For example, if you want to analyze, for example, heavy metals in a sample, and the setup of your experimental technique is wrong, is not correct to detect heavy metals, and you analyze the sample eventually, and you mentioned that the sample didn't have any heavy metals in it, then reviewers or editors may pick up on this method or this technique is not really good enough to detect heavy metals. So there might have been heavy metals in it, but you used the wrong technique. Okay, that's why we always mentioned it's very important to read high impact journals so that you can see what are the experimental designs other people are using. You can even critique, remember, even published studies, not all of them are valid. So you have to share published studies also with your supervisor and double check with them. Is this method valid? Did these researchers follow the correct method? Because sometimes there's a lot of bias in publishing as well. Then under specified methods, a study may be very robust, but its methods is not shared well enough. So someone else cannot go and repeat that work because, for example, they didn't include the concentration of the chemicals they used, or where they bought the chemicals from, or the specific technique that they used. Then the last one there, errors, is technical errors may exist in a study, such as misidentified reagents or computational errors, or errors in statistical analysis that you perform. So all of this may influence the actual outcome of research and its reproducibility. This we should avoid at all costs, because research is there to society, right? And we need to learn additional skills, attend workshops, read papers, avoid producing research that is not valid and reliable. So this is very important. And remember, producing reproducible research is also, it takes a lot of time, and sometimes researchers don't have the time or the resources to necessarily produce reproducible research. So let's look at some challenges and then some solutions. Let's look at omitting null results. We have the weak experimental design, we have underspecified methods, we have underpowered studies, etc. So some of the answers can be to share the open data, use open methods, publish journals that are open access. This is extremely important. Using reporting guidelines, like for example, in some clinical trials, you have to follow a specific set of guidelines or criteria, for example, the consort statement. And in journals, they will also specify that to report the study effectively, please consult this and this guideline. For example, consult the consort study if you've done, for example, clinical studies, and then you need to report it according to that guideline. You need to follow it to the T. Collaboration is important. In research, collaboration is extremely important because someone in your collaboration group may have access to more advanced equipment, they may have more funding, and they may have access to more advanced knowledge that can well complement the work that you are doing. Training is very important. We need to train ourselves in how to design studies, how to statistically analyze studies, how to effectively collect data, how to effectively store data. And also there needs to be more incentives in the research arena for producing reproducible research. And this can all help us to produce reproducible research. So very important how you report your data so that someone else can follow the method, ensuring that the study design that you follow is valid. The number of samples that you have for your study is not too small, but enough to reach statistical significance, and also how you write and interpret your work, the statistical analysis. Do you well interpret this? Because sometimes you will have very complicated statistics and then you will struggle to efficiently report this and interpret this. So make sure that you understand the statistical analysis and that you report it well. Okay. And also in the limitation sections of your study, it's very important to mention that there was this limitations in the study, for example, a small sample size. Why was this? Because it was a pilot study. Maybe you had a lot of patient dropouts. Why was this? And then you need to report this so that this can guide why you had this small amount of samples and how you're going to rectify it in future research. Okay, so now if we look at the career planning, and the project planning before we get to project planning. Now, in the previous sessions, we already discussed how to select a research discipline, how to select a supervisor and mentor, and grant writing. So all of these that I'm listing here, selecting a discipline, selecting a supervisor, doing grant writing, having a valid and diverse research collaboration, attending conferences, publishing well, and also speaking well at conferences, writing an effective CV that we'll have at the next session is all very important for you to understand, to effectively plan your career. So attend workshops on this, attend them, read papers on them, and ensure that you understand this very well to grow your career and your personal brand. So we already discussed in this section now briefly that it's important to conduct ethical research and also to conduct research that is reproducible. So this we already discussed. So now we're going to go to, we're still in this phase. So just in broadly, some important points you need to remember. Besides research ethics, research reproducibility, and all these things, one needs to remember certain things when planning your career. And this should be done already at the very, very early stage. It's very important to publish first author papers. So ensure that you as the student are a first author on your publication. This is important for your career. When you apply for funding, get promotion, etc., like this, when you're more senior, reviewers want to see first author publication, right? So make sure you publish a lot of papers when you're doing your master's and your PhD. In your master's, 1 or 2 papers is good. You can aim to publish even more. And in your PhD, you should be at least publishing 3, 4, or 5. Some people even publish 6, 7 papers. Balance your career on your research complement with other activities. Remember, it's very important at the early career stage to focus on your research, your experiments and publishing, but you should also complement it with training and attending workshops for you to grow your skills. Because besides just doing research, running experiments well, learning about the techniques, you also need to learn how to write well, how to present well, how to lead a team, how to apply for funding, etc. Learning to communicate your research well is very important. So attend research communication workshops. When you're doing your work, talk about your research to your peers and your supervisor so that they can help you. If you are stuck, if you're having a problem, then you need to reach out to someone, because this can sometimes lead people to procrastinate. They lose hope and then they sit there without the research progressing. Remember, there's a time limit. You have to do a lot in a very limited amount of time, and you have to finish in time to get your degree. So whenever you run into problems, try and find a way around it. Have a passion for what you do. You have to like what you do to make a meaningful contribution to it. If you are not liking what you do, you will not have the passion for it, you will not put in the effort, and you will just get bored. So do something that you really find meaning, or that is really, that you feel passionate about, that you want to make a difference with. For example, if you're doing, for example, research into purification of water, this is a big problem in Africa and the rest of the world, and this can help a lot of people against developing certain long-term diseases and etc. So if you want to develop a water purification system using advanced technology, this is a good idea, because this can really contribute to the sustainable development goals and also to community health and safety and access to clean drinking water. This is just an example that I'm mentioning. Be a team player. This is important. When you are in a research environment, you need to work well together with other people. There may be conflict, or sometimes things happen that you are unhappy with, but then you need to handle it in a very professional and constructive manner. Engage socially with your research group. This is important, to celebrate birthdays, to enjoy a lovely dinner when someone has published, and have some connection with the research colleagues around you. Very important, also take care of your physical and mental health. Research can take a toll on your health, but you should take care about your health and also about your mental health. Attending workshops about emotional intelligence is also very advantageous, because this can learn you to effectively handle difficult situations. Like, for example, if a paper gets rejected, one needs to learn that even Nobel Prize winners have had their papers rejected. This is a common thing in science. Don't let this pull you back. See it as a learning curve. They will provide you with feedback that you will learn. And even if you got rejected for something or a funding or a review, ask the editor if they can please explain to you why did they reject this application, and how can you improve this then for future. Remember what we said, spending time on research can be frustrating. Sometimes things don't work. You know, a lot of different things can happen. Remember, this is unavoidable in research. I remember when I was doing my PhD study, everything was going wrong at one stage, and I was thinking, oh my, what am I going to do now? I feel like I'm really now in a very sticky situation. And then one day I remember I went to look. In those days, it was still where you had to go to the library, and I went to the library. And I was looking for a specific paper because I got a paper back with a lot of reviewer comment, and I needed a specific paper to address one of the reviewer comment. And then just by surprise, I came across this one article, and this kind of solved my problem. I knew then, okay, if I could do this work, I could kind of solve the problems that I was having now with my PhD. So sometimes things happen for a good reason, and you will only know a bit later on in your life why this happened. So keep strong, keep going. You need strategies to minimize wasted time. So always be convinced that your work is leading to something important. Even if things go wrong, it will in the end lead you to something greater. A PhD, where you have the power to help your communities, to help other students, etc. Don't get stuck. Get help. Ask for advice, okay? And don't be afraid to ask for advice because you're still very young. There's still a lot that you need to learn, okay? Don't wear blinders. Remember, you need to keep on top of the literature in your area to see for the recent developments. Don't procrastinate. Always look for fundamentals hidden in the details. Sometimes science is very complex. A negative result may lead you to something else. So you have to very critically look at your work, okay? Challenge your hypothesis. Learn to recognize when something is not working out and then move on, okay? Remember, communication is very important. You learn how to write well, to learn to attend conferences. Always have a paper in mind when doing your research. And then when you're already starting your research, when you're busy with the method, you can already write this up, because then you remember what you have done and you immediately write it up. This will also help you to reproduce your research. When you've done the experiments, you jot down exactly the conditions, the concentrations, the time, so that you will be able to repeat it. If you leave it and you're going to write it down in a week or 2 weeks time, then you already forget, what did I do, what samples, what. So write it down and start with the methods, for example, of your research paper or your thesis. Then you already write this down. When you have the results, already summarize it. Go to the statistician, analyze it. And for example, also some people even start with the literature review when they're still busy with the experiments. So then they do the literature review while they are waiting, for example, for experimental results, because this saves you time. Learn from criticism. Remember, criticism you have to get. This is something that always happens in science and is pretty normal. Take it constructively for you to learn. Put timelines and milestones for yourself, right? Tell yourself, okay, in 1 or 2 months, I want to finish my literature review. In the next 2 months, I'll be doing experiments. And then think about also things that may happen. You may get ill or experiments may not work out, and then plan effectively for this, right? And remember, your work should represent a significant advance in the knowledge and also address societal concerns. Don't be scared. You have to ask your advisor. If you struggle, if you stress, go to your advisor. Okay, this is very, very important. Sometimes criticism is hard to take, but it's important for you to learn and grow. So now, when you're managing, when you're thinking about how you're going to manage your project, it's very important actually, because a well-executed strategy increases the likelihood of meeting your project goals and your objectives. So right at the beginning, when you start planning your project, you have now your research idea, you have your supervisor. Now you need to start planning it. Now you need to think about things like the scope of your project. Will I finish it in time? What is the quality and how can I improve it? What is the time scheduling for this? For example, in the first 2 months or 3 months, I'll be doing literature review. In 2 months, I'll be doing my experiments, but I need to include for example, 2 extra months if something happens or equipment is not available, to include the risk also, to take cognizance of the risk aspect. Then you need to think about the budget. Do I have enough funds? And also very important, what some students forget to do is make a list of the chemicals that you need. For example, if you're working in science, make a list of the chemicals that you need, because if you go to a lab, there may not be available these chemicals, and then it may take a lot of time for these things to arrive in South Africa. So plan effectively for this. Also, if you need ethical approval, plan well in advance. So by the time you start your study, you will have the ethical approval in place, because you cannot get data, obtain data from humans or animals if you don't have the ethical clearance in place. What resources will you be using? What risks may come later in your work? So you need to plan also for that. Then project planning in general is planning, scheduling and controlling of project activities to meet project objectives. The major objectives that must be met include your performance. You want to finish in time. You want to use your budget effectively and your time effectively to reach your end goal, okay? Then align the tasks in support of the project, not outside of the project. It should be dedicated towards achieving the project. Translate your project strategy into meaningful objective. You track the performance against those objectives. You highlight potential deficiencies, risks, and strengths that should be considered during the project implementation. Define the where and how will you do the project, who will do what, and estimating the when and how much. This is important. Do you have enough funds for your personal bursary and also for your experiments to achieve your end goal and successfully complete your study? Now, when you are planning your project, also there's a lot of project management workshops out there, leadership workshops, and this is important to do because you learn new leadership skills, you learn negotiation skills, you learn team and problem solving, you learn communication skills, and you learn important decision-making skills. For example, if you run into a problem, you need to make a decision, how we're going to address this, how we're going to solve this issue. So all of this will learn you, when you're managing your project well, it will learn you a lot of efficient skills for you to succeed then in the rest of your research career. So generally, the project management will involve the initiation, and then you plan your project, you eventually execute it. Monitoring is very, very important. Monitoring it in terms of your progress, your milestones, your goals. Did you at the end of the 3 months achieve what you have planned to do? And remember, the PhD can go by, or the master's or the honors can go fast, very fast. So you need to plan and you have to monitor. By monitoring is also checking the literature. Has there been a recent study published that I can follow, that I can include in my work? This is very important. Then also it involves monitoring. This is very important. Remember, the project on its own is just doing the work so that you get the results, but you have to manage that project in order for you to effectively and successfully complete your degree. So you have actions that you will be doing. You need to track those actions to ensure that you achieve those goals in time and that you deliver a good end product, that you publish well, that you attend conferences. All of these things one needs to plan. And when we get to that later, I'll explain a bit more. So during your project also, you have to ask yourself, where are we? Or where am I? At what stage am I in my experiments? Should I make more effort or work a bit harder to fast track because I only have 1 month left and I still need to do this and this? Where had we planned to be? Am I where I want to be, or what can I now do to fast track my work so that I can finish in time? Because I know, for example, I need to attend a conference in September or so, and then I need data by then. So what can I do to have my data ready by the conference time? Okay. And if something goes wrong, how am I going to address this? This is importantly related to risk management. So if something happens, if a machine breaks or I get sick or anything can happen, how am I going to handle this situation there? Can I go to another university, use their equipment instead? What if my supervisor gets sick? I remember during my PhD, my supervisor developed cancer, and this was really, really stressful period for me and really for him as well. And we were quite close. And it was really, really very difficult and stressful. So one has to think, that's why one has to also have a mentor. To have a mentor so that you can consult with and that can step in and hopefully or possibly supervise you if something happens. So these are all things one need to be cognizant about because life happens. Now, people use, let me just check how much we still have. Okay. So when you plan your project, some people can just use an Excel chart, or you can, it depends on how you want to plan your own work. You can write it down in Word, you can use a Gantt chart, you can use Excel. There's many different programs that you can use for project management. And this basically, for example, summarizes what you will be doing when. For example, you will be designing your work packages, like, for example, your experimental work will run from month 1 to 3. And then you will be describing in this work package for yourself, what will you be doing in this month, what type of experiments. And then the next month will be, for example, 1 month will be dedicated to statistical analysis. But then you already need to write down for yourself, by the end of month 3, I need to contact the statistician. Because remember, people may be on leave or they may not be available. So you need to plan very well ahead, well in advance, to check that you still keep track with your package, your work package, and your goals. Then set milestones also for yourself and go back after 1 month, go back to your Gantt chart and you see, have I done this? Did I achieve what I wanted to achieve? And why didn't I achieve what I wanted to achieve? Then you need to add in additional goals in the next month to achieve what you have not done yet. Okay, check that you keep with your budget as well and your deliverables. So this you can all summarize in your Gantt chart or in written form, any way that suits you best. Remember also the difference between a well-managed project and an unmanned ship. So if you don't really manage well your work and plan for it, you may have a loose and unfocused implementation of your project. You don't reach your milestones, you don't finish your thesis in time, all these things, all these bad things happen. Whereas you manage and you check that you're still on track with your project, you have a focused direction, you reach your targets, you publish well, and you hand in your thesis in time. Now, sorry, you can also put up like a research plan for yourself. So this is just an example. You can make a heading for yourself in a Word document or your notebook or wherever, your phone, that this is my career aspiration and what do I need to do to achieve that. So I need to think to myself, okay, I'm now going towards the end of my master's. I need to start looking out for maybe a job if I want to go work, or I need to start looking out in the next couple of months for a PhD project. I need to finish my degree in time so that I can apply for scholarships so that I can do my PhD. What is my current job responsibilities and what is the achievements I want now and in future? And then you make a list for this. So you focus on your career now and in future. And then you think about writing and publishing as well. Have I published? Why haven't I published? How many papers do I want to deliver? This is important. The more publication, the better. Then what workshops and things do I need to attend? Have a look out for these. Do I need to attend workshops on my manuscript writing? Do I need to develop my writing skills? Then I need to attend writing workshops. If I need to understand how journal publishing works, then I need to attend publishing workshops, etc. If I need to apply for a fellowship, what fellowships are there? What workshops can I attend to learn me how to apply for these fellowships? What other soft skills do I need to develop? For example, one needs to have project management skills in research, also leadership skills, all of these things. Attend those workshops. Also, what communication skills do I need to develop? Presentation skills, outreach, public engagement. Where do I stand with collaborations? How do I network well? Attend workshops on that. Do I need to teach as well? How do I teach well? Is there teaching workshops? Is there teaching opportunities? Think about that as well and plan for that as well. Here again, presentation skills, project management skills is very important, and you make a list of this as well for yourself. You can also make a list in a type of table that, do I have this skill? No, I don't have, and then what action I'm going to take to achieve that skill. Okay. What type of writing skill I need? For example, I need to learn English language or grammar, punctuation or referencing, or I need to learn argument and critical analysis type of skills. Then I attend such workshop that learn me how to argument well. If I want to apply for ethical clearance, is there a workshop maybe, or can I consult with the ethical clearance department to help me? Do I have? Then I said, no, I don't have. And then I plan on attending so-and-so date this workshop and reaching out. What do I want in my supervisor? Then you can put the skills or what you want to gain out of the supervisor-student relationship. And then also right at the beginning, when you're selecting this, we already discussed when we were mentioning about the research topic, the research question. All of this points about translational, applied, multidisciplinary, interdisciplinary, this we already discussed. So we have to ask ourselves, does our research topic align with some of these principles, the interdisciplinary research, addressing the sustainable development goal? How much time will we spend? Will we finish in time? Will it involve traveling or field work? Do I need to gain access to specific types of equipment? What is the deadline submission date for example, ethical approvals or funding to visit overseas facilities to do my work? Remember also, do not base your research question on the use of techniques only. The technique should help you answer an important scientific question. So this you can go through in your own time because I see we're almost running out of time. Then also here's some useful information on research questions and research problems. So how to refine your research question. The keywords that you use in your literature review, have a look at that. Also think about that also, which search engines you will use. Ask yourself, what is the problem that you're trying to investigate? What are the arguments? What are the limitations? Which websites should I look for? Which articles should I use? Which search strings or keywords shall I use? Also, remember when you're constructing your aims and your objectives, there's a difference between an aim and an objective. Those are some documents that you can consult. Then your methodology, your design, do you need ethical clearance? What is your, if you're working with humans, what is your exclusion and inclusion criteria? You need to describe the site that you're visiting, or if you're doing environmental study, the environmental area that you will be sampling from, how you be doing your sampling collection. This is very important. For example, sometimes, in studies where they'd be doing environmental toxicology, they will be collecting human samples, for example, the nails, for example. And if they clip nails, then with a type of scissor that contains a metal, this can transfer metals to the tissue, and then you may get a kind of biased result. So read up on, for example, how to collect samples, for example, when you're doing toxicological studies. This one needs to be very clear about. For example, then you need to use ceramic scissors because these won't transfer any metal contaminants to your sample. So there's a lot of little things to think about. What consumables do you need? Are there any safety considerations? Sometimes people will work with chemicals. This is very, very, very important. We had an incident here some years back where a person here was working with pure sodium, and they didn't read the material safety data sheet of the material that they were working with. And in the end, they worked in the open environment with the material, and it exploded, and it caused them severe harm, third-degree burns, and a lot of pain and trauma. And this person is still recovering. So when you are working with chemicals, read the material safety data sheet. If you will have to work in the fume hood or in wearing gloves and a mask, follow this, because chemicals can make a lot of damage. I remember one night I was working with in my master's, I think. I was still a young student and I was working with a chemical. I had very little time. I didn't have time for this. And when I opened the bottle, there was this terrible fume coming out that completely took my breath away. And then afterwards, I read how really dangerous this chemical Wow, so please read and plan your experience well. If you're going to work with dangerous chemicals, make sure you use the correct protective gear. Then how you will manage data, which statistical analysis you'll be using. Will you be using basic and which multivariate statistic, because there's a lot of them. You need to ask the advice of your statistician. Also the power analysis, these things. A statistician can really help you in planning well your studies. Then again, you need to manage well your project. You need to plan who's going to do what and by what time are you going to do these things. Okay. What else? Now this is all related to project management. This you can read. Also your budgeting is very important. You need to stay within your funding. Will there be any risks and how will you plan to overcome these risks when things don't work out? So that's it.